Okay, so we were talking about the Wi-Fi technology, IEEE 802.11, and we are talking about the multiple access technologies. We learned this last week. So there are different strategies. One of them is called avoid collisions. Uh, when the two plus nodes are transmitting at the same time in order to avoid the collisions. So one of the solution was CSMA, if you guys remember, carrier sense multiple access. So the idea is very simple. So you're gonna sense the channel before you transmit. So in other words, don't collide with ongoing transmission that is done by other nodes. in uh, in Wi-Fi technology is a wireless technology. That's why there is no collision detection, because it's difficult to receive sense the collisions when transmitting due to the weak receive signals because of the channel effects, fading, shadowing, and so on. And it cannot sense all the collisions in any case because of the hidden node problem or fading or shadowing problems. So that's why we are trying to avoid the collisions instead of detecting the collisions. So that's solution is called CSMA CA, collision avoidance. How this CSMA CA multiple access protocol works. Let's look at the timing diagram. First, we start with the Wi-Fi sender, and this is our sender, this is our receiver. In the first step, if the sense channel is idle for this interframe spacing time, let me show you. Within this time duration, DIFS, we sense the channel. If this channel is empty, is idle, is not being used, then we transmit the entire frame. So no collision detection basically. If the channel that we sense is busy, then we need to wait. So that's why we start the random backoff time, and the timer counts down while the channel is idle. So once the time is expired, we transmit our packets. If no acknowledgement, then we'll increase the random backoff interval and we'll repeat this step 2. At the receiver side, if the frame received OK, then we return the ECK packet after SIFS duration. So that's why we use the avoiding collision strategy in the Wi-Fi technology. And the main idea behind this strategy is to allow the sender to reserve channel rather than random access of the data frames. So by doing this, we avoid the collisions of long data frames. How this avoiding collisions works, the sender first transmit a small packet which is called RTS, request to send packets, to the access point using the carrier sense multiple access protocol. But these eventually these are packets. These request to send packets may still collide with each other. But if they collide with each other, since they are short, so our loss is gonna be small. So the base station or the access point receive this RTS and send a response, which is called clear to send, CTS, in response to the RTS packet. And this CTS packet are heard, listened by all the nodes. So sender then transmit data frame, other stations defer their transmission. So simply how it works, if you want to summarize. So if I'm a mobile phone, I want to access to the access point to the link. So I'm telling this to the access point, hey, I want to send some packets by sending the RTS packet to the base station, the access point. And the access point receive my request and then send a CTS packet, broadcast actually CTS packets. It says, hey, everybody listen to me. This guy, this specific mobile device is going to talk to me. So I am reserving, assigning the channel to this specific guy, specific mobile device. So it broadcasts this CTS and everybody, listen and receive this CTS and they become quit only. They quit, they become silent, the others, and only that specific mobile device access to channel and it's sent its packet. So by by utilizing this collision avoidance protocol, so we avoid long data frame collisions completely, but using some small reservation packets. So let's look at this RTS CTS exchange. We have the access point. We have the wireless host A and wireless host B. So both, they want access to this link by sending RTS to the access point. As we mentioned, it's possible that these RTS may collide with each other, so which is not too much important since these packets are very small. Our loss is small basically. And then RTS resend is RTS packets. Assume that now is successful. The access points, obtain this, receive this request, and then broadcast the CTS to all wireless hosts in the network. And then the wireless host start to send its data. The other guys, such as the wireless host B, it defer its transmission. And once the access point receive the data of wireless host A, then it's broadcast the acknowledge to the network. Okay, that was about the multiple access protocols for the Wi-Fi. Let's look at the frame structure in terms of addressing. So we have in the frame structure, we have addressing fields such as address 1, 2, 3, and 4. Address 1 is used for the MAC address of wireless host or the access point to receive this frame. Address 2 is MAC address of wireless host or access point transmitting this frame. Address 3 is allocated for the MAC address of router interface to which AEP is attached. And address 4 is used only in ad hoc mode. And then we have some fields such as CRC. If you guys remember, these fields is used for the bit error detection and correction. So let's give a specific example how this addressing works. In address 1 field, we have the access point MAC address. The router, the access point that is going to receive this packet, and we have the MAC address of the transmitter, which is in this case is it's host 1, and then we have the router 1, the MAC address of the router 1, which is access point is attached. So the access point is gonna relay this packet to the router, and in this case is 80.11 frame is utilized. In this case, we utilize the 80.3 frame between the access point and the routers. Okay, so let's look at the other fields, such as the duration of the reserved transmission time, which is utilized for the RTS, CTS, and frame sequence number for the reliable data transfer, if you guys remember. So as you see, there are many different fields. Okay, so let's talk about the mobility within the same subnet. Host 1 remains in same IP subnet, so that's why IP address can remain same. But let's look at the switch, which access point is associated with host 1. We learned this, remember, from the chapter 5 when we learned the self-learning topic. Okay, some advanced capability of the Wi-Fi technology, which is called rate adaptation. So, as you know that when the mobile device move around, so the SNR can change. So the base station, in this case, the access point can dynamically, compensate this change by switching between different modulation technique. So let's look at this one, for instance. SNR decreases. So as the SNR decreases, bit error rate is going to increase because of the movement of the mobile device. So then the base station, it's going to change the switch. It's going to change the modulation from QAM 256 to QAM 16, so that we can keep the link going even with the low data rate. So when the bit rate becomes too high, then we switch to the lower data rate, but with lower bit rate. So that's what is called rate adaptation in Wi-Fi. So the idea here is, if the channel become worse, the link quality become worse, we reduce the data rate so that we can still keep the link alive. Another advanced capability is called power management. You know, the power management is important because these are mobile devices. They have a limited battery life. So in order to improve the battery life, there's some mechanism which is called power management. So first of all, node to API. If a node is not gonna transmit any packet, it tells to the access point, hey, I am going to sleep until next beacon frame. So by this, the access point knows not to transmit frames to this specific node. But the node is gonna wakes up before the next beacon frame. So it sleep within one beacon frame. So what information contains in this beacon frame? It contains the list of mobiles with access point to mobile frames that is waiting to be sent. So node will stay awake if that specific node is within this list. Otherwise, it's gonna sleep again until the next beacon frame. So with this way, we try to save some power by sending the node to the sleep. Another wireless local net area network technology we talk about so far is 802.11, which is a Wi-Fi technology. But we have other wireless local area network, such as 802.15, and this is the standard for the personal area network. As the name implies, is a personal area network, is basically short-range network, less than 10 meter diameter that we are talking about. And what are the main application is for the replacement of cables, such as the wireless mouse, wireless keyboard, and wireless headphones, such as AirPods. So in this case, we use ad hoc mode. There's no infrastructure, no base station, no access point. So in ad hoc mode, we have two type of nodes. One of them is the master node, the other are slave nodes. So as you see, we have an M master node, we have S slave node, and some P node, which is our parked inactive device. So how these networks operate? So in this case, the slaves request permission to send to the master, and master grants request. So one of the popular technology in this standard is Bluetooth, and it operates in this 2.4 gigahertz band, and the data rate can support is up to 721 kilobit per second. Okay, that was about wireless local area networks such as Wi-Fi and Bluetooth. Now we are ready to move to the cellular internet access. So let's start with the components of this cellular network architecture. First of all, we have a public telephone network, public telephone network, and these are connected to the mobile switching center. And this mobile switching center, they coordinate multiple base stations. So this, hexagon is called cell, and it covers the geographical region. So in each cell, usually we have a base station that is responsible to handle multiple mobile devices. So in the middle, usually we have the base station, which is like a access point in the Wi-Fi technology. And we have the mobile users, which are attached to the network through the base station. And we have a link. In this case, it's called air interface, physical and link layer protocol between the mobile and the base station. And we talked about the mobile switching center, MSC. The main function of this MSC is to connect this base station, the cells, to the wired telephone network. And it's also responsible for the managing the call set up the call. And also it's responsible for handling the mobility. And this is the wired network. So we have different multiple access technology in these cellular networks. There are two techniques for sharing the mobile to base station radio spectrum, and one of them is the FDMA, TDMA. We already mentioned in one of the previous lecture. So we divide the spectrum in frequency, channel, and divide each channel into time slots. And in CDMA, we already talked about CDMA. It's a code division multiple access. We assign a unique code to each mobile user. So this cellular network, as you know, it starts with the 2G GSM, and it was initially intended only for the voice communication. So in like 1990s, our cell phone, they only works for the voice communication. You can talk over the phone, that's it. There's no internet connection, no data connection. So that's why the architecture was given as follows. We have the mobile device, and which can connect to the BTS base transceiver station through the wireless link, and the BTS, they are connected to the BSC base station controller, and the base station controller is responsible for this base station system, and these multiple BSC are connected to the mobile switching center, and then mobile switching center was connected to the gateway mobile switching center, and then wired network. That was the initial, the one of the, it was first architecture that is intended for only voice communication. So after that, the success of 2G for the voice communication, so the user starts to demand for the data communication to access to the internet. So that's why they add another parallel chain, as you see. So we keep this voice communication chain, and we add a new chain for the data services. So as you see, now the name changed to the BSC to the RNC. The name is called RNC, the new radio network controller. And this is can handle both voice. When the voice call comes, it forward to this chain, MSC. But when the data comes, it can forward to the SGSN. And then this is connected to GGSN, serving GPRS port node, gateway GPRS port node. So the voice network unchanged in the core, we just add a parallel data networks. So there's some notation that we use from RNC to the mobile is called radio interface, which has different technologies such as WCDMA, HSPA. From here to here is called radio access network, UTRAN. And from this RNC up to here is called core network. And in this case, we use the GPRS, General Packet Radio Service core network. And then after that is a public wired network. Okay, that was about the main principle of cellular networks, including 2G and 3G. Now, we come to the important point, which is the mobility. So my device is mobile. So I'm here and I'm using my mobile device, smartphone at home, but after 2 hours, I'm gonna go to school and then I'm gonna use there. But how the network track my device, and if some call come to me, how the network finds that I'm in university area or I'm in home, so that it can forward that call to me. So that is called mobility management. So let's look at the mobility management, starting with the main principles. So the mobility can be at the different level. So in one extreme point we have no mobility, in the other extreme point we have high mobility, and there are different levels between this no mobility and high mobility. When you say no mobility, mobile wireless user using same access point. Okay. When you say highly mobile, that means mobile user passing through multiple access points. You know, like a cell phone, you are in the car and you are driving with 100 km/h, and you know you keep changing and handover from one base station to another base station. You are highly mobile. And we have some, you know, different level between these two extreme points, such as at the middle, like a mobile user connecting, sometimes disconnecting from the network. You know, this is the mobility level. Okay, so how we handle or how do we manage the mobility in the wireless networks? And so in order to explain this, we need to talk about some main concept starting with the home network. As the name implies, this home network is a permanent home of mobile. It is the permanent home of mobile. And we have a permanent address in this home network. So can always be used to reach this mobile. And in this home network, you have an agent, which is called home agent. This entity is responsible to perform mobility functions on behalf of mobile, even the mobile is remote. So now we have another type of network, which is called visited network. So network in which mobile currently resides. It has specific IP address, as you see, mobile IP address. And of course, still this mobile device has a permanent address. This always remains constant. And we have a care of address. This is a temporary address in the visited network, because let's say I'm at home now. I went to school. I go to school, and this is my visited network. In this visited network, we have a foreign agent. Entity in visited network that performs mobility functions on behalf of mobile. And we have the care of address, which is the temporary IP address in visited networks. And the last notation that we use is called correspondent. This is the device that wants to communicate with the mobile device. Okay, so how do you contact a mobile friend if you don't have a cell phone or the mobile phone? Assume that your friend is frequently changing the addresses. How do you find her? In the past, we have the phone books. Now, you guys, I think you don't remember. We have the phone books, and we open the books and look at the names and find the phone number of that specific person. Or we call her parents. Where is this girl? Or you're gonna, wait and let her to call you to tell you where he or she is. These are some, ways to find your friend. But when it comes to the mobile network, we are talking about the millions, maybe billions of the mobile devices. How we are going to find a specific mobile so that we can connect and talk. There are two main approaches. The first one is let routing handle it. And the second approach is let end system handle it. So let's look at the first approach. Is based on the routing. So the routers is going to advertise the permanent address of mobile nodes in residence by using the routing table exchange, if you guys remember from the routing that we learned. So these routing tables is going to indicate where each mobile is located. So there's no changes to the end system in this approach. But this is not feasible, this is not practical, not scalable, because we are talking about millions of billions of mobile devices. So if you keep change this table, the network may be congested. So this is not scalable. And the second approach, let end system handle it. In this case, we have two methods. The first one is called indirect routing. The second one is called direct routing. So indirect routing, communication from the correspondent to the mobile goes through the home agent, then forwarded to the foreign agent. In the direct routing, correspondence gets foreign address of mobile, and then it sends directly to the mobile device. This is called direct routing. Each of these method has some pros and cons that we're gonna see. So first of all, your mobile device, when it's gonna join to a mobile network, we need to register. So this is called registration. I have home network, I have visited network. So if my mobile is is visiting to this network, let's say your school network, and then uh, first of all, it's gonna register to this visited network. So the mobile contacts to the foreign agent when it's entered to the visited network. Then this foreign agent is gonna contact to the home agent that is gonna tell to the home agent, hey, this mobile device is resident in my network. So at the end of the day, the foreign agent knows about mobile and the home agent knows the location of this mobile. So after the registration, let's say there's a correspondent and one of your friends wants to talk to you. So the correspondent, first of all, is gonna send the packets using your home address of mobile, your permanent address basically. And then home agent, it intercepts this packet and it forwards to the foreign agent that is just registered, remember, in the visited network. And then the foreign agent is gonna forward this packet to the mobile device. And then mobile is gonna reply directly from itself to his friend, which is the correspondent. So this is called indirect routing. So let's talk about a little bit about the indirect routings. What are the advantages and disadvantages? So first of all, the mobile devices uses two addresses. One of them is permanent address that is used by the correspondent. So that's why it's transparent to the mobile location is transparent to the correspondent. So in this case, your friend or your correspondent doesn't know where your location is exactly. It always sent to the permanent address. The care of address is used by home agent to forward the datagrams to the mobile device. Foreign agent functions may be done by mobile itself, okay. But there's a problem with this indirect routing because we have a triangle routing problem. It's an inefficient when the correspondent and mobile are in the same network. So as you see, it keeps on to the home network, then from home network is routed to the visited network. That's why it's inefficient. Okay, so you're at school now, you are gonna go to the library with your friend, so you move to another network. What's gonna happen? So suppose that you are moving your current to another network. You're from one visited network to another visited network. We follow the same steps. First of all, we need to register with this new foreign agent, and the new foreign agent is going to register with the home agent, and home agent is going to update your care of address for your new location, and the packets is going to continue to be routed to your mobile, but with new care of address, of course. So the mobility changing foreign network is transparent to the correspondent. And there's no cut in your current connections, so the current connection can be maintained. Okay, let's look at the second method we talked about, is direct routing. How this direct routing works. In the first step, the correspondent requests and receive the foreign address of mobile, the care of address of mobile. and then the home agent is going to send this care of address of mobile to correspondent, to your friends. So now the correspondent has your care of address, so it doesn't have to go through the home agent. So it directly sent to the mobile device through the foreign agent, of course. In the third step, foreign agent receives these packets and it forwards to the mobile device, and mobile replies directly back to the correspondent. This is called direct routing. The main difference, we remove this connection between the home network and the foreign network. So the direct routing, it solved the problem of triangle routing problem that we mentioned. In indirect routing, is non-transparent to the correspondent. Now the correspondent know exactly your care of address. So that solved the triangle routing problem. What if mobile changes visited network? So let's look at this. I visited this network now. I'm talking at the same time I change my visited network during the session start. What's gonna happen? So first of all, there's a new concept called anchor foreign agent. The foreign agent in the first visited network is gonna be anchor, your anchor foreign agent. So that means the data always is gonna route through this anchor foreign agent. So when mobile moves, the new foreign agent is going to arrange to have data forwarded from old foreign agent. It's like a chain. So it's going to go through this anchor foreign agent. Okay, these are the main principles of the mobility management in cellular, in wireless networks. And let's talk about this mobile IP concept. Mobile IP is a standard, and the standard number is RFC 3344. It has many features that we learned so far, such as home agents, foreign agent registration, care of address, encapsulation, and so on. So 3 components to standard. One of them is the indirect routing of datagrams, agent discovery, registration with home agent. So let's look at the indirect routing that we just learned. We have the permanent IP address, starting with 128, and we have the care of address in the visited network. The IP address example is 79, and so on. So the correspondent, when it tries to send a packet to mobile, it utilizes the permanent address as a destination. And then the home agent, it intercepts these these packets and encapsulate into another packet by putting the destination as your care of address. And then the home agent send these packets to the foreign agent. So the foreign agent receives this packet, it removes the other preamble, and then send this foreign agent to the mobile packet. So another process called agent discovery, through the agent advertisement. So the foreign home agents advertise service by broadcasting the ICMP messages. So it's here. This is the standard ISMP fields, and these are allocated for the mobile IP agent discovery. And we have different fields such as HF bits, home and or foreign agent, R bit registration required, and so on. And this is the the care of addresses. Let's look at the registration mechanism in mobile IP. Each of them, they have their own IP address, as you see, home agent, home address, care of address, and mobile address. So first of all, foreign agent is gonna send an agent advertisement message, and then mobile agents receive this and reply by sending the registration request, and the care of address is 79 and the home address is 128 119 blah blah, and the mobile address is 186, and then it passes these packets to the home agent. Home agent reply the registration to the foreign agent. Foreign agent relay this registration to mobile agent. So by these steps, we complete the registration process. So remember the main components of the cellular network we talk about. We have the mobile devices, and we have base station that are connected to the mobile switching center, and then they are connected to the public telephone networks. So each of these blue region can represent different mobile operators. So how do we handle the mobility in the cellular networks such as 2G, 3G, and LTE? So we have similar concept which is called home network. This is the network of cellular provider you subscribe to, such as Turkcell, Türk Telekom, and Vodafone. Within this home network, we have a database which is called HLR, Home Location Register Database. This is the database in home network that contains your personal information, your cell phone, mobile phone number, your profile information, and so on. In the visited network is the network in which mobile currently resides. So in these visited networks, we also have a database which is called VLR, Visitor Location Register Database. This database has entry for each user currently in network. So let's look at the indirect routing in GSM case. So this is correspondent. Your parents or your friends wants to talk to you. So it's initiate a call. This call is routed to your home network, first of all. And in your home network, you have a home agent, right? So before home agent, we have this home mobile switching center. It consults this database, HLR database, to get the roaming number of mobile in visited network. Once it gets your roaming number, it's gonna set up a second leg of call to the mobile switching center in the visited networks that you are currently there. So MSC in visited network completes this call. It set up the call through the base station to the mobile device. Now you are connected end to end, and then you can talk to your friends. So another important problem is handoff or handover. So what is the main goal objective in handoff is route the call via new base station without interruption. So assume that you are in the car and you are talking to your parents, but you're moving very fast. So you're actually connected to this old base station, but because of the movement, you're getting far away from this base station, and the strength of the signal is decreasing. So that's why we need to hand over your call to the nearest base station. So what are the reasons for the handoff? It can be different reason, as I mentioned, because you are moving away from your serving base station. So you need to hand off to a stronger or a new base station to continue your connectivity and less battery drain. Sometimes we perform the handover in GSM to achieve the load balance, because some of the base stations that are, let's say, close to a stadium that is there's a soccer game or football game, so there are many people, and the load of this base station is very high. So in order to free up channel in that base station, we hand off some of the call to another base station to achieve the load balance. So the GSM standard doesn't mandate why to perform handoff. It only tells you how to do it. So the handoff mechanism is initiated by old base station. Let's look at the typical handoff mechanism in GSM. Consists of 8 steps. So the first one is first step, the current serving base station informs MSC that is going to perform the handoff by providing the list of neighbor base stations. In the second step, MSC set up path and allocates the resources to the new base station. And then in the third step, new base station allocates radio channel for use by mobile. And then in the fourth step, the new base station signals MSC and old base station by saying that, hey, I am ready. And then in the fifth step, the old base station tells mobile to perform the handoff to the new base station. In the step 6, the mobile and the new base station signal to activate new channel. In the 7th step, mobile signals via new base station to the MSC, so it performed its new link through the new base station to the mobile switching center, and then handoff is complete. So the MSC is gonna reroute call, and in 8 steps, MSC tells to the old base station that handoff is completed, so and tells to release the resources. So these are the 8 steps of an handoff mechanism in GSM networks. Any questions so far? Okay, what if mobile device move from one visited network to another visited network? So in this case, it's similar to the Wi-Fi case. Anchor MSC is utilized. What's the anchor MSC in this case? Is the first MSC visited during the call. This, for instance, this is the first MSC. That's why we call anchor. So if the mobile device moves from this network to another network to another network, it always goes through this anchor MSC. So call remains routed through the anchor MSC. And as we add a new MSC, so we need to add this new MSC to the end of MS chain as mobile moves to the new MSC. There's some method to minimize these paths, basically this chain. Okay, let's look at the element of this mobility in GSM as well as the mobile IP. In mobile IP, we call it home network, and this is called home system in GSM. In mobile IP, we have the home agent, if you remember, and this is called home MSC or home HLR database. We call visited network in mobile IP, the correspondent element is visited system. The foreign agent in mobile IP correspond to the visited MSC or VLR database, and the care of address in mobile IP, it correspond to the roaming number in the GSM literature. So what is the impact of mobility on higher layer protocols? So logically, this impact should be minimal because the best effort service model remains unchanged. And we utilize the TCP and UDP at the transport layer to run over wireless and mobile networks. But performance-wise, we may have more bit errors because of the packet loss, because of the wireless links as well as the handoff. So in this case, the TCP interprets loss as a congestion, and it will decrease the congestion window unnecessarily. For the real-time traffic, we have some delay impairments, and most importantly, the wireless link have some limited bandwidths compared to the wired links. So to summarize the chapter 6, what we learned today in terms of wireless technology, we have a wireless links. What are the capacity, the transmitter, the distance between the transmitter and receiver can affect the performance of wireless links, some channel impairments, and more specifically, we talk about the CDMA as a multiple access technology. And then we move to this most popular technologies in wireless networks such as Wi-Fi, and we talk about the collision avoidance. And then we move to another popular technology, which is cellular access. We talk about the architecture, some standards, including the GSM 3G. So after this one, we talk about the mobility, which is one of the important problem to handle in the wireless networks. Starting with the main principles, how do we handle the addressing and home visited networks through different methods such as direct, indirect routing? What are the care of addresses? And we study some case studies such as mobile IP and mobility in GSM. All right, so we are done with this chapter 6. Any question? No?